Good morning. So this video I am going to discuss about a simple trick to find bond order of molecules and ions. Okay, so this kind of problems we can expect in any entrance examination. Now the question number 1. So you are given some species. You have to find out bond order, and you have to arrange those species either in the increasing order of increasing order of bond order or decreasing order of bond order. So here you are given actually 5 different species: C2, C2 2 minus, C2 plus, O2 molecule, then O2 2 minus ion. Okay, so now these are supposed to arrange in the increasing order based on their bond order. Okay, so now first let us calculate bond order of these species. So carbon bond order is about that we have already discussed in the previous video. Okay, so if you watch the previous video, you can understand how the bond order of carbon molecule is about 2. Okay, now let us go for C2 minus. Carbon molecule with 2 extra electrons. Okay? So carbon electronic configuration you know very well. Carbon atomic number is 6, isn't it? So that it has the electronic configuration 1s2, 2s2, 2p2, isn't it? Right. So this is what electronic configuration of carbon atom: 1s2, 2s2, 2p2, C2 2 minus, isn't it? So that there are 2 extra electrons. One I have added with the first carbon. Okay. Similarly, electronic configuration of another carbon atom: 1s2, 2s2, 2p2. The one more extra electron I have added with the second carbon. Okay. So these are the 2 extra electrons comes due to 2 minus charge. Okay. So now in the outermost orbital there are 6 electrons in the bonding molecular orbitals, isn't it? Therefore NB value is about 6, whereas anti-bonding molecular orbitals are empty, so Na value is about 0. Right, now the bond order formula is NB minus Na divided by 2, isn't it? Now let us substitute the values. NB value 6 minus Na value 0 divided by 2. 6 by 2 is nothing but 3. Therefore bond order of C2 2 minus, bond order of C2 2 minus species is about 3. Okay, so just remember this. Right, next let us calculate the bond order of C2 plus ion. Okay, C2 plus ion. C2 plus ion, carbon molecule with lack of 1 electron, isn't it? So we have to reduce 1 electron from carbon molecule. Now we have written 2 carbon atoms with electronic configuration. First one with 1s2 configuration, 2s2, then 2p2 electrons. For the first carbon I have written all the 6 electrons what it has. Then second carbon, 1s2 configuration, 2s2 configuration, 2p1. So I have reduced 1 electron. I have reduced 1 electron because this molecule has C2 plus charge, isn't it? Which means it is supposed to lose 1 electron, isn't it? So this was the actual configuration of carbon, but due to plus charge it has lost 1 electron. Okay, so I remove this electron. Right, now the number of electrons present in bonding molecular orbital is about 3. Anti-bonding molecular orbitals are empty, it is about 0. Okay, right, now let us substitute in the bond order formula. NB value is 3, Na value is 0 divided by 2. 3 by 2 is nothing but 1.5. Therefore bond order of C2 plus ion is about 1.5. Okay. Similarly, we can go for oxygen. So oxygen bond order calculation. So I have done in the previous video. If you watch it, you can easily understand it. Just watch the previous video and understand how the bond order of oxygen is about 2. Okay, then now let us calculate for O2 2 minus ion. O2 2 minus ion. Okay, right, now so this is oxygen molecule with 2 extra electrons. What does it mean? Oxygen molecule with 2 extra electrons. So now I have written the electronic configuration of oxygen. You know very well oxygen atomic number is 8. So electronic configuration is 1s2, 2s2, 2p4, isn't it? Okay, right. Now the first oxygen atom with 8 electrons. 1s2 electrons, 2s2 electrons, 2p4. Plus I have added 1 extra electron, isn't it? So this is due to presence of 2 minus charge. Oxygen molecule with 2 extra electrons, isn't it? 1 electron I have added with the first oxygen atom. Okay. Similarly, the electrons of the second oxygen, 1s2, 2s2, 2p4, 2p1, 2, 3, 4, plus this is the extra electron which comes due to 2 minus charge. Okay, so O2, 2 minus oxygen molecule with 2 extra electrons. One extra electron I have added with first oxygen, another extra electron I have added with second oxygen. Okay, right. Now, so these are the electrons in bonding molecular orbital. Now you can see in the valence orbital, the bonding molecular orbitals is completely filled. So NB value is about 6. Then anti-bonding molecular orbitals are filled with 4 electrons. So that Na value is about 4, isn't it? Right. Now let us substitute these values in formula. NB is about 6, Na is about 4 divided by 2, 2 by 2. So I am getting 1, isn't it? Therefore bond order of O2 2 minus ion, O2 2 minus ion is about 1. Okay, right. So now we have completed calculating bond orders. So I have written the bond orders. Carbon molecule 2, C2 2 minus 3, C2 plus ion 1.5, oxygen molecule 2, O2 2 minus ion is 1. Okay, the question is write the species in the increasing order of their bond orders, isn't it? That is increasing order in the sense least to most, least value, starting with least value and ending with the most bond order value. Okay, right. So which one is having least bond order? This one, isn't it? So that O2 2 minus, less bond order than 1.5, C2 plus, then O2 molecule and C2 molecules are having equal bond order. So that I have written them together, C2 and O2 with same bond order, about 2. O2 2 minus, bond order value 1.0, this is 1.5. Both these are having value 2.0. Then the last one, bond order 3, ion with C2 2 minus, bond order 3. Okay, so this is the increasing order of molecules based on their bond order. Okay, right. I hope you understood this problem. Now I give another problem based on bond order. Okay, question number 2 or example number 2. Bond order of a molecule is about 2.5. The number of electrons present in bonding molecular orbital is about 8. Now the question is, how many electrons are present in anti-bonding molecular orbital? Now you are supposed to find out the number of electrons in anti-bonding molecular orbital. Normally we calculate bond order from electrons in DMO and ADMO. Here bond order and electron in DMO are given. They are asking number of electrons present in anti-bonding molecular orbital. So this is the formula for bond order. Now let us substitute the values. Bond order is about 2.5 and number of electrons in DMO 8 minus Na is what we are going to find out. This is what we are going to find out, divided by 2. So after rearrangement, finally I am getting Na value is about 3. Okay, therefore the number of electrons, present in anti-bonding molecular orbital, is about 3. So when you substitute in the formula, you are supposed to get bond order 2.5, isn't it? So there you again, NB is given as 8 minus Na you have calculated about 3, minus 3 divided by 2 in the formula, isn't it? 8 minus 3, 5 by 2, which is nothing but 2.5. Okay, so the bond order is correct. Okay, so now the final answer, number of electrons present in anti-bonding molecular orbital is about 3. Okay, right. Then one more problem. So you are given 3 species. Which among the following 3 has highest bond order? Okay, so you have to find out the one which has highest bond order value. Nitrogen molecule and N2 plus ion and N2 minus ion. Okay, so bond order of nitrogen molecule we have calculated in the previous video. Just follow the previous video, watch it and understand how it is done. Then now let us go for N2 plus ion. Okay, right. Nitrogen molecule N2 plus, which means nitrogen molecule with 1 electron less, isn't it? Right. So now, so this is the electronic configuration of nitrogen molecule. Nitrogen atom 1s2, 2s2, 2p3, because it has atomic number 7, isn't it? Right. Now these are 2 nitrogen atoms combined to form N2 plus ion, isn't it? So the electronic configuration of first nitrogen with 7 electron, 1s2, 2s2, 2p3, right. Then second nitrogen atom, this is second nitrogen atom with electronic configuration 1s2, 2s2, 2p2, 2p3 actually, 2p3 is the actual configuration of nitrogen, but this has N2 plus charge, so it has unit positive charge, isn't it? Which means it is supposed to lose one electron. Okay, but now I remove this electron from the nitrogen atom. Okay, right now you can see the bonding molecular orbitals are filled with 5 electrons. Nb value is about 5. Antibonding molecular orbital is empty. Na value 0. So now I calculate the bond order using the formula Nb minus Na by 2. So Nb value 5. 5 minus Na 0 divided by 2. 5 by 2 is nothing but 2.5. Okay. So that N2 plus ion, the bond order is about 2.5. Okay. Similarly, let us calculate for N2 minus nitrogen molecule with one extra electron. Okay. The two nitrogen atoms, that's 1s2, 2s2, 2p3 configuration. Another nitrogen, 1s2, 2s2, 2p3 configuration. But if you look at the example, N2 minus, it has unique negative charge. So there is one extra electron. Okay, that is supposed to be filled in anti-bonding molecular orbital. Okay, so now the number of electrons present in bonding molecular orbital is about 6. Anti-bonding molecular orbital is about 1, isn't it? So substitute in the formula Nb value minus Na divided by 2. 5 by 2 is nothing but 2.5. Okay, right. So nitrogen bond order is 3. N2 plus ion 2.5. N2 minus also 2.5. Okay, right. Now the question is, which one of the species among these three has highest bond order, isn't it? It's nothing but nitrogen. Okay, so the answer is highest bond order is exhibited by nitrogen molecule, whereas the bond order is about 3. Okay. But I hope you understood how to do the problems which are based on bond order. Thank you. Keep watching my other videos also. Thank you very much.